Now we're gonna hear Richard Gross about fixing the $1 billion mistake, and he is on the screen right now. Yeah, people probably weren't expecting you right now, but better earlier than never, right?
Well, I don't mind.
Assume our audience.
I can try talking about an event source system, but I'm pretty sure I wouldn't do as good a job or any good job at all.
I am absolutely sure our audience is more than happy to hear you speak right now. Am I right? They're just nodding, but they don't understand that you cannot see them at the moment. So you should make some sound, okay? Can I? In 3, in 2, about now? Thank you. You can tell, Richard, that it's Friday and we had a party yesterday, right? Okay, stage is yours.
I took part in the party, so yeah, I can tell. I think I had a bit more sleep than the audience. Cool. So I'm sorry for not being there in person. I had planned to. I had a flight, and then something happened in my private life, and I'm sorry I can't come. Nevertheless, it's awesome to be here. It's awesome how well this works remotely, and I mean, yesterday's party, like part of the band was remote, and it still worked. It was amazing. Okay, a quick things. Before I start, first of all the example code is available on GitHub. You will see the link at the end. The slides are on speaker deck. You can already see the link. And if you want to reach out, you know, I'm on Twitter, or I don't know, blogging, if people still do that. I do sometimes. Cool. Let's start with fixing the $1 billion mistake. And I want to start with the money question. Well, let's see. There we go. So what is the most dangerous errors a programmer can make? Take a moment to think about it. What's the most dangerous error you can make? You know, this is so much greater when you can actually see the audience. So I think every 2 years, the CWE like announces the top 20 or actually top 25 most dangerous software weaknesses. So I took and analyzed like the top 20 and just wrote it down here. And if you thought the most dangerous error was the null pointer, sorry, that's not it. It's actually manual memory errors. Things like out of bounds, read or write. And then below that comes the things, well, a lot actually, about input validation. So cross-site scripting, operating system, command injection, interesting stuff like uploading the wrong or uploading a dangerous file type and you don't check that and your system scans it, and then you get like dangerous vulnerabilities. And, you know, in the keynote this morning, you saw it. The integer overflow is actually at number 12. We saw the binary search in Kevlin's talk this morning. I just took the moment to copy the code in there. The red line is the one that has the integer overflow. That's at number 12. And finally, at number 15, we finally have the null pointer dereference, which is what this talk is about. And then to complete the circle, we have authentication and authorization issues. Things like they're simply missing or you have done them improperly or things like that. Take note that by most dangerous, I mean it's the most common and impactful issues experienced over the last 2 calendar years. And also take note that I fudged this graph a bit. It's not this specific order. These categories sort of bleed together, but manual memory is still at the top. Input validation is sort of right next to it, and auth is sometimes a bit above the null pointer dereference, but it's, it's close enough. So handling null is important, but it's not the most dangerous mistake. if you're writing a website or, well, any production grade system, the most dangerous thing is not null. Still, it's not null, but it happens a lot. So the company OverOps, they actually published 2 blog posts about this, and they said that 97% of logged errors are caused by about 10 unique errors. So this graph is maybe a bit hard to understand. At least I got the feedback. If you look at this pie chart, these 97% of errors are caused by, well, the 10 unique errors on the right side. And I just printed the top 3. And the number 1 by frequency is certainly the null pointer exception. And that's important because you will probably have a lot of null pointer exceptions in your business code. And since you're paid, well, mostly for the business code and all the other stuff is just glue around it, that's kind of important. And in 2009, Tony Hoare actually held a talk about, well, he called it his $1 billion mistake. So he invented the null reference in 1965 when he designed the next evolution of the algol programming language. And he says it has led to so many errors, vulnerabilities, and system crashes over the years that it might have amounted to about $1 billion of pain and damage. And of course, I mean, Tony Hoare, he certainly did invent quicksort and a lot of stuff you might have heard of at university, but he did not design C#, Java, or Python. Now, why did he do this? I mean, he has a complete talk about this, but the short summary is he had the problem that his company was selling algol machines, and they needed to run, I think, Fortran code on these algol machines to actually sell the machines, because if you cannot run the programs that people have, well, they're not going to buy your machine. So he actually, or his team, I think, wrote a transpiler from Fortran to algol. And the funny part was they couldn't compile the code. It just crashed. It said, okay, well, I don't know the specific name, but for our intents and purposes, it's like a null reference error. And customers weren't happy about that. They were like, okay, but I want to run the code on this algol machine. Otherwise, I'm not going to buy a PC. Well, your algol machine. And he invented instead of compile time crash, the runtime crash, so to speak. The transpiler could have detected it at compile time, but he made it into runtime error because otherwise you couldn't even run your code. Okay. So, dealing with nothing, or dealing with this null. How could we, or in modern languages, how could we deal with this instead of making it a runtime error? So let's say you are a programmer and you're now designing a dictionary. This dictionary is used by this nice addresses class, and when you access from address the person ID, well, applying the principle of least surprise, if you access the addresses by person ID, what should this return when person ID is unknown? And at least in my mind, you have the following solutions. You have the implicit, you just throw an exception. So that's what C# does, that's what Python does. You could also go for the alternative. You could return this null we deal with probably every day, which is what Java dictionaries actually do. You could do something like a default value. So if you were to store like instead of an address, you would store an integer, you could return 0 as a default value. Or the thing I wrote in the code above is the Null-Object-Pattern, a specific instance of address which is meant to represent null. But that all of that is implicit. You cannot see it in the type system. You could also go for something explicit. Instead of just saying, okay, access it by index, you have to require default. The method requires you to say what to return. And we have that as extension methods, for example. And the other way is you model the absence, which is something that Scala or Kotlin or F# do. But you know, how would that look like? And the benefit of that is you could write code like this: const address, addresses.find, and you know, address could be null now. And you cannot just ignore it, because this piece of code would create a compiler error, because the compiler says, oh, well, address could be null, so you cannot access just street like that. You have to check it before use. You have to say address is not null. And you cannot access it without explicit check. So, you know, the same thing that Tony did or could have done, and he actually talks about what he could have done, so his talk's pretty great. You move it back from a runtime error again to a compile time error. So you actually know at compile time that this works, or, well, it can't because it doesn't compile. And the question I have is just, you know, wouldn't it be nice if C# had explicit absence? So we have a bit of a trend in the history that our languages become always more secure by taking away options. So if you were the original programmer, you wrote zeros and ones, and zeros and ones you could do anything with. You could just, I don't know, access a memory structure that doesn't even exist. But over the years, the options you had as a programmer, they were taken away. They were deemed, I don't know, dangerous. And like the original paper about this one was the one, Go to Considered Harmful, which is actually not the original title. It's just the title that the editor assigned. Actually, it was called A Case Against the Go to Statement. And out of this paper came this idea that instead of having like a jump or go to statements in code, you had very if, else, for, while, and, you know, one return per method. So instead of being able to jump anywhere, you had very explicitly defined control structures. And then other languages came around and people were like, okay, oh, manual memory, that's kind of considered harmful as well. And we got things like garbage collection, we got things like reference counting, or, well, very recently, at least for programming languages, we got ownership models that Rust is very much known for. I think Ada is also known for ownership models, but I haven't checked this. And then right now we have things like implicit null considered harmful. And we get solutions like optional or maybe, or this thing called nullable. And you can see this more secure trend even in more and more languages being introduced. So in 2005, you had F#, and they write on their own language marketing page, they write, well, it's a robust language. And it actually has null, but you cannot assign it to anything. And it only has null because you need to interoperate with .NET code. And you have Rust, and they write about themselves, well, it's a reliable language. And it doesn't even have null. And you have Kotlin, and they say it's modern, concise, and safe. And they even have this, well, this quote on their page directly. I think, I don't know, item 4 or something. And even Swift, in 2014, they say it's a safe language. And they mostly have nil for Objective-C interop. So this concept, sometimes it's called null safety. Wikipedia calls it void safety. There's a trend. All the new languages are already incorporating this. And luckily for us, our languages evolve. And things that were true 20 years ago are no longer true, and things you couldn't express 20 years ago are now expressible. And when we look at what I call them the big three, Python recently being the #1 programming language. I'm sorry, I didn't write JavaScript here because it's, well, it's got dynamic types and you cannot define them at compile time, so it doesn't quite fit the talk. And why Python is here, you will see in a minute. Let's see, where do we start? All right, C#. C#2 got generics. And why generics are important, I'll explain in a minute as well. And it got this thing called nullable value types. So you could make integers, you could make int nullable, which they introduced, well, now 16 years ago. And they introduced this null coalescing operator to work with nullable integers. But you couldn't make something like classes. You couldn't make objects nullable. You could only make primitives or value types nullable. And then in 14, Java introduced this optional thing. So they have this option concept that wraps around your value and makes sure you cannot access it if it's null. And then Python, to my surprise, actually got type hints in 15. And you could even write something like, well, this type is optional. You could write it with the type in Python. And then in the same year, C#6 introduced more null propagator or null propagating operators that just help you a lot with working with, if this thing is null, do that. Or only if this thing is not null, sorry, the other way around. And then finally, in 2019, we got C#8 and .NET Core 3+, and they introduced finally nullable reference types, which is mainly what we will talk about today. Oh yeah, forgot about this. So C#9, the next year, they made some improvements to generic nullability, and they added cool classes like records and init-only setters that really help you make sure the stuff is really null and make it very nice to handle that. And yeah, I think C#10 doesn't have that big improvements to nullability, at least. It has really cool improvements for performance and other things. And it came out 1 week ago, so I just wanted to mention it. Cool. So how can we fix the mistake in C#? Take a look at this. Where do you think the error is? And I mean, I think everyone immediately grasped this. Obviously, it's notebook. You get a null reference exception and so on and so on. But the interesting part is why? I mean, I wrote this code. An employee always has a notebook. And the answer is, well, under certain conditions, an employee does not have a notebook. And you as a programmer, you don't know this because this feature was added later after you wrote this code, or maybe just forgot. But a notebook can suddenly be null, and the original code didn't plan for this. And specifically, the type does not reflect this. So the stack trace we saw was pretty much useless because it showed us, yes, okay, here's the nullity reference, but it didn't show us why. Why was it suddenly null? Why wasn't it null before? And if you now want to improve this code, if you really want to go for the compile errors instead of runtime errors like this, and I urge you to, you have mainly two ways of doing this. And one is you can enable it in your CS project file, say nullable enable, and lang version 8, or, well, I encourage you to go for 9. And you can say warnings as errors, nullable. And that was really important because if you don't put this here, then yes, your IDE will show it like yellow and say, okay, well, this is bad, but you're not really forced to handle it. And I encourage you very much to enable this feature to say warnings as errors. Nullable is an error, not a warning. If you, however, have like a huge code base that is not that modularized, you can try out this feature per file. You have a precompiler notation, and you can enable it. So everything between line 2 and line 13 now has nullability enabled. And you can do that per file, but it's really tedious. So if you have like nice modularization, take the day or take the 2 days to actually enable it and make warnings as errors. And after you enable this, going back to the original example, suddenly, well, this assignment, the place where the bug came from, is a compile error, which is exactly what is helpful, because now I'm not fixing the symptom, I'm fixing the cause. And the cause goes on, and you have to model this. You have to go to the employee class. You have to say, okay, well, this can be nullable now. And now the previous code compiles. But now you get like this sort of cascading compile error. Here we only have one, because it's very simple code. But depending on your code case, it really goes on like this. And it's like, okay, well, this and this and this. And that's where the very interesting stuff happens, because you suddenly have to think about things that could occur, and maybe they occurred quite a lot in your code and just didn't quite know where this problem came from. And now you have to talk about it, talk to your product owner or whoever, because it's often a business error or an unspecific business case that no one really thought of. And now you have to think about it. And that's really where the the cool stuff happens, because you start modeling new ways and interesting ways. And the other cool part is the compiler really guides you through the code base. If you make the nullability into errors, you have no choice but to handle it. But it really helps you. It's like, okay, well, here and then there and then there and then there. It might be like a lot of errors at the same time. So go through them one at a time, and not all of them at once. But he really helps you in this case. And yeah, I said this before, we fixed the root cause thanks to nullability and not just a symptom. Yeah. And quite frankly, we could stop this talk now. The compiler helps you, you enable it, and that's it. But there's a bit of things we can do to make the null handling a bit more effective, a bit more fun, actually. So let's talk about effective nothing in C#. So as a short recap, think of this address repository that we discussed before, specifically the dictionary. You had these 5 ways to handle this. And C#8 picked this nice way. You can model it explicitly. You can say find address. Address might be null. This nice question mark in there. And you use the get value or default extension method. Or you explicitly should do that instead of the indexer. And the syntax is quite simple, actually. If you look at line 2, this will no longer compile once you enable it, the nullability. Instead, you have to go to line 4. You have to use the null propagating operator. Or maybe, depending on what your business logic is, you can go for something better, theoretically. It depends if a default is applicable in this case. You can use the null coalescing operator to say, well, if the thing on the left is null, then take the thing on the right. And now address is no longer nullable. It's just address. It always has a value, and the compiler knows this. Or you can make this a bit shorter, depending on the use case. You can use the null coalescing assignment operator, where you say, okay, well, line 8, address might be null. If it's null, then use the default. And going back to much earlier in the talk, you can also use this new pattern matching syntax to check if this value is null. You can still use equals null or not equals null, but the new way in C# it's a bit more semantic in my opinion. This is speak. So you say is null or is not null. And now you can finally model this absence explicitly in C#. And that's why I think that nullable reference types are more important than the introduction of generics. Because the same way today, you cannot think about writing code that, you know, a list where you don't know what type is in there. The same way, I don't think in the future you will be able to write code where you don't know that something is null or not null. And I think that migration is worth it because you'll catch so many bugs. So speaking of migration, so suppose your system kind of looks like this. You have multiple CS projects, which are these verticals, and then you have comments below, comments for language extension, comments errors. All of these are separate. All the gray boxes are separate CS projects. And then up there you have these adapters. I call them edge elements. So if something like a JSON comes into the system, that's being handled in this adapter. And I would encourage you to, well, simply start with a simple project. Take something small or something unimportant, you know, it could also be large and unimportant, and just migrate it completely all the way through with one-axis errors. And after you get a feel for it, then, at least if you're on C#9 or higher, go for some common projects next. So your, I don't know, your language extension, your error extensions, and that stuff. Why C#9? Because in C#8, it's not so nice dealing with generics and nullability at the same time. And in C#9, so far, I've not had any problem at all. It was quite nice. And then after that, you know, focused steps. Take one project, migrate that, take the next project, migrate that. Don't try to migrate all projects at the same time. You will already get the benefit from just migrating one project because you will find null problems and you will talk about your talk to your business analyst and solve it. And you don't get lost if you just take one project. You can finally finish one. It might also be that you stop and say, okay, well, this project is too large. I need to revert all my changes and start with a smaller project next. Or, I don't know, split up the project before I migrate it. And yeah, don't trust the edge. The edge elements are kind of evil. And we'll talk about this shortly. So now you've enabled nullable reference types. How can you use them more effectively? And there are 5 or 6 points I want to mention. And one is, well, always specify when returning null. That's the core one. And really, I don't even have to put it on the slide because the compiler will tell you, well, this doesn't compile. You have to handle it. But still, you know, just to be thorough. The next one is return empty collections or arrays, not nulls. So on the left, you say under certain conditions, iList is going to be null. And that's going to, well, be very annoying for all the people who use the APIs, because now they have to check 2 different cases. They have to be like, oh, if it's null, I do this. If the list is empty, I do that. And it's much nicer, especially if you use iterate over this list with link, to just be able to return an empty, like this, just an empty list of stuff. In C#9, you got this nice feature called Init-setters. So you can, instead of the set you're probably accustomed to, you can write this init. And that means it can only be set during initialization. So if we look at line 2, that's where you instantiate it. And then in line 7, you cannot change port anymore. Port says, oh, well, I'm an init setter. You cannot set me now. Doesn't compile. And you can use it very well for configuration with known defaults. Because in line 4, port is marked as non-nullable, and we know the default port is 7070. Or line 5, well, app name can be null, so default is null. But they are very much useless for domain types, because for domain types, the default values are probably unknown, or, you know, not generic enough that you can always apply the same default. And actually, this code won't compile because it says, oh, well, I don't know that city will always be, I don't know. At compile time, I don't know that city won't be null. So if we have this, we need to write a regular constructor and assign it in the constructor. It's a bit tedious, but it's compile safe, or specifically, it actually compiles, which the left side doesn't do. And if you really want to go for the domain types, and if you go for domain types in general and use C#9, I would encourage you to use records. They're pretty much awesome for this case. So instead of the init-setters on the left, use a record on the right. You can see it's even shorter than the declaration on the left. And you can initialize it pretty much the same way. You say new address and you just pass in the parameters. And they also provide additional stuff. They provide this nice thing called value equality, where you can say line 15, oh, well, if I have created address 1 and address 2 with exactly the same values, well, then address 1 and address 2 are equal. They're equal because their values are equal, not because they're, and they just ignore reference equality. And if you need to mutate them, you have this thing called non-destructive mutation. You can say this thing in line 17, you say address 2 with, and then you pass in the new value. And now because of this value equality, line 20, address 2 and address 3 are no longer equal because you changed the value. Again, don't trust types from the edge of your system. So if you deserialize line 1 to an employee DTO, all these nice values, ID, name, email, they'll just be null. But the type system doesn't tell you about this. I mean, that's kind of a library thing. I hope it's going to be fixed soon, but it's very, very important that you keep this in mind. So make sure when you create an employee DTO or something like this, when you get some JSON from outside and you transform it into a real domain type, that you always check if these values are actually null. That you always check that these values are not null if your domain object assumes them to be not null. Because I didn't say this before, but nullable reference types and nullable value types are implemented in a very, very, very different way. And nullable reference types are implemented mostly, or I think only as a compiler feature. So the types at runtime don't change that much. While a nullable value type actually changes the types. Now, one more thing. So you've now gone ahead and you've enabled nullable reference types, but now you've got all these null checks everywhere and it kind of looks ugly. And I say, great, you fixed the root cause of many bugs at compile time. And that's important to keep in mind. It's if you get all these compiler errors, well, it's something you didn't consider before. You had like this undefined state where you didn't know what happened. And now you have to handle it. And that's good, but it might make your code look a bit ugly. And I brought this very, very short example. So let's say you create an employee. You first deserializing from the body, you check the email address of the employee is unique. Then you store it, then you email the employee and say, okay, I just registered you. And then you return an okay response. The problem is, now it actually looks more like this with error handling. So you first check the employee is null. And I only put one null check here. You can probably imagine very simple scenarios where there's 3, 4 null check, and we'll always have this thing, if it's null, do this. But to keep it short, I only focus on this. But you also have other error handling, and it becomes much, much harder to see what the happy path is. I mean, I colorized this. I made everything white. That is, the happy path, but it kind of is harder to read. So can we clarify the business rules again? Wouldn't that be nice? Or clarify, can we write code in a way that the business rules are much easily observable and, not hidden in all this stuff, in all these, error handling, basically. And I want you to take this one more thing moment to make a very, very, very shallow dive into railway-oriented programming, which is something that is probably more familiar to F# programmers because it was introduced by Scott in 2015, I think. And don't expect to know everything about railway-oriented programming in this shallow dive, but I wanted to show you this just in case you have the situation and you may be able to apply it in your case, and to just give you a quick peek. So let's go back to the happy path. So this was our happy path without error handling. We don't have this null check. We don't have this try catch exception thing in there. And you remember then with the error check, it kind of grew to the double size, right? So if we apply the concept from railway-oriented programming, it will look like this. It will kind of be pretty much the same lines, right? The only thing is the thing I marked in gray is this result builders. So the first one is you get the employee from body, and that might be null. The result of that might be null. So you say you do this extension operation as result, and you say, well, if it's null, then okay, I have this invalid employee passed. And then I try something. I check if the email is unique. And this try, this short phrase try in there, signals check email can fail. But you can still chain the next thing together. You can still then say store employee, but it only goes to line 5 if the previous lines haven't failed, if employee from body wasn't null, if check email is unique, hadn't failed. Only then you store the employee. And then you try to email the employee. That can also fail. For example, if the server is not reachable, or you have a weird business logic and the email address of the employee might have a duplicate, then this email employee can also fail. Or the email address actually might not be, better example is the email employee might fail if the email address is unknown of the employee. And then if everything has completed, you go into line 7, you say, okay, response, this has worked fine, cool. But this okay response is only returned once everything above has worked. And you can see, you can sort of see your business logic again, because it's right there. You get the employee from body, you check the email, you start employee, you don't have all these if conditions in between. They are still there, don't worry about that, but they're sort of abstracted away behind this result object. And that's kind of the thing about the railway-oriented programming idea, at least in C#. In F#, it's simpler to implement, it looks much nicer, but in C# you have to create its own type. So on the left, you have this nice happy path. On the right, you have your error path. And you can, with the then, you stay on the happy path, assuming everything before that worked out. And with the then try, you see this try in there, you might go back to the happy path, but you might go back to, go to the error path as well. And at some point you might be, okay, well, that's all great, but I have these things where several things can fail, but afterwards I can recover, I can go back. And for that, we have the method called then try fix, which can also fail, can also, say, okay, well, the color's wrong. It can go back to the happy, but it can also, it's a try. You don't know if it succeeds. It can also go back to error. And then fix is definitely, okay, I'm going back to the happy path from my error path. So let's say your email employee failed, but you're like, okay, that's all right. The emailing employee can fail. I'll just send him, I don't know, a fax instead. So then you can apply this fix. And if you want to get on the rail, you take your regular domain object and you say, okay, I create this okay, which is a wrapper method, or use this fail, where you have to specify why it failed to be able to later create a nice response from that. Or the if of result, which, depending on if the something is null or not, goes to the happy or the sad path. Now, in case you like this, I have to do a disclaimer. Because the same guy who created this, or who presented this method called railway-oriented programming, he also wrote a blog post a couple of years later called Against Railway-Oriented Programming. And his concern was that people started wrapping exceptions and creating them into result objects. And if you do that, you lose the stack trace of the exception. You don't know where the problem was anymore. And you go for something like stringified programming, because you can put the error message into your failure result, but it's just a string, and so you know, if you want to know which exception it is, you sort of match the string of the text, which doesn't help you at all. So whatever you do, don't wrap all exceptions with the results. And use railway-oriented programming only for domain errors. So domain errors which don't throw exceptions. How to get started? Watch a deep dive talk, not a shallow one, like this one. Switch to F# if you have a choice, it's pretty cool. Or copy code, so you can either code your own result, C# result class, or you can copy the one I put into the GitHub. Now we're done. Examples are available on GitHub. Everything I talked about. I'm definitely not the first to talk about this. So there's the original talk by Tony and John Skeet, who introduces nullable reference types. I'm not at all the first one to talk about railway-oriented programming. People have done it in F#, in C#, in Java. At least to my knowledge, that's it. But you know, you will probably find more of that. And we're done.
Okay, let's see if we have any questions about this. Also, my mixed up about the information before that our agenda was different from what's happening. Apparently, some people saw the right agenda, some people saw the wrong one. So some of you probably expected what you saw. Let's see. What about the audience questions live? Will we have any? Anybody? Hello? If you want to have questions in your session, you better ask him a question now. It was too complicated. Oh my God, Richard, it was too complicated for smart people right here. Okay, apparently it was, because we don't have online questions either. Okay, I will let you talk to them. So which part was complicated?
Oh my God, it was so... Come on, Elder, you have to do this for me.
Well, I'm an architect, so I don't use this stuff anymore.
That's an excuse.
You're the developer.
No, really, I just cannot actually consume information just by listening. So I need to sit down, have a look on the code, and run it and see it, and then I will have questions. So I'll get back to you, definitely.
Please do. You can see the code in the link. I've included a lot of tests, which should guide the way. And the presentation is already online. So please do.
Okay,
and
I feel
ask
like
questions using Twitter or something.
I feel like I just set you up on a date. Ritis is asking, can we find the slides somewhere? I think you showed the link for that, right, in the beginning?
It's, let's see, there. Bottom right corner, speaker deck.
I was told to repeat the question. Is it possible to code without any nulls at all, like avoid them completely? It seems that nulls are here to stay.
Absence of value is here to stay. So if you have an address and the street is not necessarily required, there are addresses without streets. You have to represent somehow that this thing can be optional. But null itself, that's programming language specific, and some languages don't have it. Some languages call it by nil, by a different name. So null doesn't have to stay. This thing that this value doesn't have to be there, or this dictionary might not return a result, you need to represent it in some way. But null can go away.
Thank you. Also, we have a question. Where is the question? Somebody deleted the question. Just like you answered and somebody deleted the question. I assume it was around the same topic. Okay, Dave is asking, do you recommend mixing C# and F# to implement ROP? I'm not sure what that is.
Wow. No. I wouldn't see the benefit of that. You can express things cleaner, shorter, and better in F#. So I guess if you have a legacy project that you want to transition to F#, you might need, sorry, I'm answering the question as I think about it. If you have a legacy project, which is C# and you have a new F# project, then you might be able to do it in a nice way. But honestly, the interop it's okay. The interop between F# and C#, it's okay, but I wouldn't recommend it. Honestly, maybe someone who's much better at F# than me might disagree, but I don't think you should do that.
Okay, if that's clear. Anybody from the live audience? One more question. We have time for one more question only, I think. Okay, then the last question comes from Gintautas. Fluent validation would clean up the filtering. What are ROP benefits in this case? I'm not sure it's correct English all the way, but I hope you understood.
I think so, yeah. So fluent validation you can use if your JSON comes in and you just say, okay, well, this one and this one needs to be that and that value. Yeah, that's true. And that is pretty much where fluent validation usually ends. You try to use it at the edge of your system. Or at least I've never seen an example where it continues. But now we're talking about handling errors in your domain. So you already have the object, you already know it's valid. And then a lot of stuff can happen, a lot of stuff can be null. And that's kind of where this ROP concept comes in. You have domain errors and you want to deal with them. I know I also put in this employee ID from path, from body, which is where your fluent validation would live. I just put it there for completeness sake, not because you couldn't do this one method at the beginning with fluent validation.
Okay, thank you very much. That would be all for the questions on this session.